or higher life forms. For their part, the cyanobacteria developed out of earlier, even simpler life forms that could also survive without oxygen. These unknown organisms colonized the Earth 3.8 billion years ago. Without them, we would never have had a chance to see a rose. Where did this life come from? That we don't know. And where does the rose get its water from? That, too, has its own story and goes further back than the story of the air. For a long time, we were content with the observation that in the early period of our planet, steam had come out of the interior of the Earth as a gas. But how did the water get into the center of the Earth in the first place? It could only have been locked up in there when the Earth was formed. 4.5 billion years ago, lumps of stone and dust that were revolving around the sun combined to form the planets. The Earth was formed from material that was moving not far from the sun. However, it is practically impossible that this debris was damp enough to make Earth into the blue planet. The heat of the nearby sun would certainly have dried it up. So originally the Earth was presumably dry, a desert planet. We don't know precisely how it turned into a world of oceans. The scenario that seems to be the most fantastic of all possible explanations is in fact the most likely one. Water came to us from outer space. It arrived in comets or asteroids that, born in the colder regions of the solar system, hit the desert planet Earth like gigantic snowballs. Thus the lakes, rivers, and oceans were filled with the melted ice from the comets. Dewdrops from the cosmos moisten the leaves of the rose. Finally, the rose owes the strong force its light. The name of this elemental force is actually too modest, for the strong force is far and away the strongest in nature. It holds atomic nuclei together. It is released in the interior of the sun, where the atomic nuclei of hydrogen fuse to become helium, releasing immense amounts of energy that radiate out into space. Hydrogen, that combustible material, is the oldest of all substances. Since the very first minute after the Big Bang, hydrogen has been present throughout the cosmos. All the elements were baked from it in the furnace of the stars, again as a result of the strong force. Everything around us on Earth was once the ash of the stars. The carbon of which the germ bud consists also comes from it. The rose is metamorphosed stardust. The stars that brought forth the rose, however, were born of clouds of hydrogen. As a result of their own gravitational pull in the cosmos, those clouds became so concentrated that they eventually ignited. The first starlight shone out. Did the stars then give birth to themselves? For a long time, that was the assumption. Today we know. The stars, too, needed outside help. The hydrogen in the universe wasn't sufficient to condense into clouds by means of its own gravitational pull. Left to itself, it would simply have spread evenly over the cosmos, like sugar dissolving in tea. The gases would never have concentrated. Not even a single star would ever have shone in the sky. The universe would have remained without form. Something heavy must therefore have started it all by attracting the hydrogen, causing it to form clouds. Something we don't know. As this something doesn't shine and also remains otherwise invisible, we call it dark matter. What this dark matter consists of, what characteristics it has, we do not know. Many of these connections were unknown to Richard Feynman, who reflected on the beauty of the rose. One of the most important scientists of the 20th century, he died in 1988. But in recent years, our knowledge of the formation of the world has expanded dramatically. We are now able to trace the history of the universe back to the first millionth of a second after its birth, at least in broad outline. We know of habitable planets outside the solar system. We have discovered a system 40 light-years away with 7 planets similar to Earth, and must assume that the night sky conceals more planets than the stars that shine. We are aware of physical processes that are contrary to our notions of space and time. Even very recently, the idea that knowledge of this kind might be possible was still regarded as adventurous speculation. Today it consists of facts that are substantiated by measurements right down to the decimal point. But our knowledge is merely an island in an ocean of ignorance. And whenever we manage to extend the island, we also